This is the test review for moles. What I'm going to do in the beginning of this review is I'm going to go over the test, and then I'm going to allow to play 11 sample problems that I took from the lecture. Each of these sample problems represent a type of calculation that you need to be able to do. According to the map that I have drawn many times, you have to be able to convert from moles to mass, moles to the number of particles, moles to volume. You have to be able to convert from mass to moles, number of particles to moles, volume to moles. Then you have to be able to convert between mass and volume, mass and number of particles and mass, number of particles and volume, volume, number of particles and volume, and mass. Going through moles. Sounds like a lot, but if you take each conversion separately, it becomes very routine. Now, let's begin with the test. As always, the test requires a standard knowledge, as in vocabulary. So there'll be a matching right away. It depends on what form you have, and that will depend on what row you sit in, and that will depend on, I guess, luck. But for some of you, you'll have to start with matching. Representative particle, mole, Avogadro's number, percent composition, standard temperature and pressure, empirical formula. I also have here things like, what are the SI units for the various things that you're going to calculate? For instance, what is used for representative particles in a substance? What's going to be the SI unit? Well, again, it's moles. I see another problem where it says, how many hydrogen atoms are in 5 molecules of isopropyl alcohol? You'll remember from the text that we started off by saying, right, if I have one molecule of carbon dioxide, one molecule, I know I have 3 particles, total 3 subparticles, 3 atoms. Well, and then I say, well, if I have 10 particles of carbon dioxide, that gives me 30 total atoms, etc. If I have 1 mole of carbon dioxide, that means I have 3 moles of atoms, etc. So you have to be able to do problems like this. How many hydrogen atoms are in 5 molecules of isopropyl alcohol? So you look at the formula of isopropyl alcohol, you find out how many particles, how many atoms there are in one particle, and then you multiply it. In this particular one, you're going to find, well, I have to simply count the hydrogen. So each hydrogen contains 7 hydrogen atoms. I have 5 molecules, so draw the appropriate conclusion. It doesn't say how many moles, it says how many molecules, right? So then you're going to have to do things like how many atoms are in X moles of a substance. You're going to say how many molecules are in X moles of a substance. For instance, I'll read one right off for you. How many molecules are in 5 moles of carbon dioxide? That's one. How about this one? Ethanol is composed of carbon, hydrogen, and oxygen. If 2 moles of ethanol contains 6.02 times 10 to the 23rd atoms of oxygen, what is the subscript of the oxygen in the formula that's given? Okay, easy? Not a problem. Okay. So then I'm going to say, well, what's the molar mass of I'll give you a formula. Let's say aluminum pyrophosphate. Well, that's kind of complicated, isn't it? Well, what is aluminum pyrophosphate? Well, remember, we've already done chapter 9 by the time you take this, so aluminum pyrophosphate is Al4P2O7 So you have 4 aluminum, then you have to add up you have 2 phosphorus and 7 oxygens per every one of pyrophosphate, so you have 3 pyrophosphates, so you can determine the number of phosphoruses there. You add it all up, find the molecular mass of aluminum pyrophosphate, and then whatever the atomic mass unit, total atomic mass units are, then that's going to be the molar mass of 1 mole of that. So when they ask you what the molar mass is, for instance, sodium chloride, something simple, I know that's 58 AMUs for one formula unit of sodium chloride. Well, so the molar mass would be 58 grams. So those are going to be some problems. You're going to be given is what are the number of moles in X grams of a substance? So you're going to have to convert from moles, from mass to moles. Here I have how many moles of a substance are in 5 grams, so you're going to have to, again, another mass to moles. You're going to have to do all the conversions. If you look at the map in the beginning of the next section that we're going to do, if you have that map drawn out nicely and colorfully, you're going to be able to draw a lot from that. No pun intended. Okay, so then the next major thing you're going to have to be able to do is you're going to have to be able to do percent compositions and empirical formulas. One really is the opposite of the other. Okay, let's look at, before we do that, let's look at what is STP. What is the volume of 1 mole of any gas at STP? Well, I know that it's 22.4 liters of any gas at STP, standard temperature and pressure. Standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere or 100 kilopascals. Okay, now, which expression represents the percent by mass of nitrogen in ammonium nitrate, for instance? Okay, so you don't even have to do the calculation. You simply have to find the expression that will give you that number. You're given a percent. Let's say you're given a percent 80. 80% bromine and 20% calcium. What would be the empirical formula of that substance? You'll remember we'll do that in class. So there's a lot of different conversions that you're going to have to be able to do. I'll give you a short answer conversion. Okay, a short answer conversion. Are you ready? It says, a short answer conversion, a short answer problem. What is the percent by mass of hydrogen in aspirin? What is the percent by mass of hydrogen in aspirin? So I'm not giving you the formula for that. So there you have it. So let's stop here and then we'll go on to the next section of the test review. This is a little bit of a different kind of test review because it's so important for the rest of the book. So let's stop here and then we'll look at the next section. And if you can do all of the sample problems, you're going to be cooking. You're going to be doing very well. All right? Have a great day and goodbye. So the first thing I want to look at is the map. Let's just start at 12 o'clock and go clockwise. You see we have 3 hands. We have the volume of a gas at STP, that's 22.4 liters of 1 mole at STP. And then you have representative particles, there are 6.02 times 10 to the 23rd particles in 1 mole. And then you have the mass, which means that the mass in grams of 1 mole of any particle is equal to the mass of 1 particle in atomic mass units. That is, the mass of 1 particle in atomic mass unit of a mole of 1 particle is equal to the molar mass. The mass of 1 particle in atomic mass units, and if I take a mole of that, that's equal to the molar mass. For instance, sodium chloride. Sodium 23, chlorine 35, it's all rounded. 58 atomic mass units is 1 particle. Therefore, a mole would have a molar mass of 58 grams. Okay, now, so if I'm going to convert from mass to moles, I have to simply say, okay, let's say I have 58 grams of sodium chloride. So I would say, all right, 58 grams, how many moles is that? So I'm going to divide that by the molar mass, which is 58. So 58 divided by 58 is 1. So it's going to be a simple proportional relationship. Mass of 1 divided by x equals the molar mass divided by 1 mole. Simple. So let's say I have 116 grams. I have 116 grams of sodium chloride. So I would say this. I would say 58 is to 1 as 116 is to what? 58 grams is to 1 mole as 116 is to x moles, and vice versa. Simple. Simple proportional relationships. Next, volume of a gas. All right. Well, if I have 44.8 liters of a gas, how many moles is that? Well, I'd say I have 22.4 liters in 1 mole. Right. So that equals 44.8 liters over x moles. And that would be the proportional relationship that you set up. And you can do the same thing for representative particles. Simple stuff. So now let's say we want to convert from representative particles to mass. Well, you simply go through moles. You got to convert everything to moles. Moles is at the center of the clock. So everything has to be converted into moles, and then it simply becomes 2 separate problems. Very simple. So it's really a repetition of the same simple construct, but you're simply making it a longer problem. Okay? So what I have 11 sample problems, 2 through 12, and I will allow them to play, and I will just simply, and I'll put them on for 30 seconds each, 40 seconds each, and I'll just simply let them play and come in if I think I need to do a little bit of a narration, but they're all very well worked out. Okay? So, have a good time. Good luck on the test. I'll see you a few more times during this. And don't forget, when you're doing a proportional relationship, it's cross multiply and divide. And a lot of the problems are set up like the book does, where you're doing a dimensional analysis thing, and it's what the book does. But remember, if you just set up proportional relationships, it's the same exact thing. You will do the exact same number, the exact same types of conversions, if you simply set up proportional relationships instead of their factor label method. And the proportional relationships, that method will be more descriptive of the chemistry concepts involved. Okay? Hold on and let me reset everything and we'll begin. Well, the first one, magnesium is a light metal used in the manufacture of aircraft, automobiles, wheels, tools, garden furniture. How many moles of magnesium are in 1.25 times 10 to the 23rd atoms of magnesium? Well, you could say 1.25 times 10 to the 23rd over x equals 6.02 times 10 to the 23rd over 1 mole, and then x, then solve for x, cross multiply and divide. Or you could simply understand that I want to divide 1 mole into that in terms of the number of particles, and so I divide 6.02 times 10 to the 23rd into it. Other than that, you can simply follow the book's method and things cancel, etc. nicely. So I'll come back in a little while, and remember, if you have any questions, ask me in class. If there's anything that you don't understand relative to these problems, let me know. And I'll do one of the problems on the board or something like it. Okay? Have fun. Notice I put the map in between these. What I decided to do is look at the first slide of each sample problem and simply try to give you some helpful hints on how to approach it and how to look at them so that you can get a quick idea of what to do. Propane is a gas used for cooking and heating. How many atoms are in 2.12 moles of propane? Well, how many atoms are in? All right, so, well, I know I would get the number of molecules, which would be 2.12 times 10, 2.12 times the quantity, 6.02 times 10 to the 23rd, and then multiply that by 11. And then that's essentially what I would do. So let's go on to the next one. But you guys, you can, you want to continue to watch this. All right, this one is the decomposition of hydrogen peroxide provides sufficient energy to launch a rocket, although rocket fuel, remember, is something a little bit different. What is the molar mass of hydrogen peroxide? Well, it's going to be of one particle, so it would be 2 plus 32, which is 34. So the molar mass of hydrogen peroxide is the mass of one particle in atomic mass units. So it's going to be 16 plus 1 plus 1 is 34 grams. And that's how I would do it very quickly. It says the aluminum satellite dishes in figure 8, you'd have to look for figure 8, are resistant to corrosion because the aluminum reacts with oxygen in the air to form a coating of aluminum oxide. This tough resistant coating prevents any further corrosion. Remember those satellite dishes in New Mexico, those monstrous dinosaurs? What is the mass of 9.45 moles of aluminum oxide? Well, what you would do is you'd add up for one particle would be 2 aluminums and 3 oxygens, so that would be the mass of 1 mole, and then simply multiply it by 9.45, and that's the answer. Easy enough, fair enough. It says when iron is exposed to air, it corrodes to form red-brown rust. Rust is iron 3 oxide, Fe2O3. How many moles of iron 3 oxide are contained in 992.2 grams of pure Fe2O3? So you'd look up the mass in grams of Fe2O3. So you take one particle, say you'd add up 2 iron and 3 oxygens, and then you would get the mass of the molar mass. So you say 92.2 grams, divide by the molar mass is going to be the answer. And you can see it's going to be considerably less than 1. Next, it says calculate the volume of a gas at STP. Sulfur dioxide is a gas produced by burning coal. It is an air pollutant and one of the causes of acid rain. Determine the volume in liters of 0.6 moles of SO2 gas at STP. It'll simply be 0.6 times 22.4. Simple, easy peasy. It says the density of a gaseous compound containing carbon and oxygen is found to be 1.964 grams per liter at STP. What is the molar mass of the compound? What is the molar mass of the compound? Well, you'd simply say, well, I need to find the mass of 1 mole. So you'd simply say 1.964 grams over 1 liter equals X grams over 22.4 liters. And that would be the answer. Simple proportional relationship. Because you know the volume of 1 mole of any gas is 22.4 liters. It says when a 13.6 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.4 grams of oxygen is obtained. What is the percent composition of this compound? Well, you know that it's going to be, the oxygen is going to be 5.4 divided by 13.6 times 100. And then that's going to be the oxygen percentage. Then the other material, magnesium, will be 13.6 minus 5.4, which would be 8.2-ish. And then you simply say that divided by 13.6 times 100 would be the percent of magnesium in the sample. So it says propane C₃H₃, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. Right. So you'd say you find the total mass of one particle, which is going to be 3 times 12 is 36, plus 8. 36 plus 8 is 44. So you'd say 36 divided by 44 times 100, that's the percent carbon. And then 8 divided by 44 times 100 would be the percent hydrogen. Easy peasy. And it says, determine the empirical formula of a compound. A compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? This problem is probably one of the more difficult problems in the chapter. Well, what you would do is you would assume 100 grams. So then you would say you'd convert to moles, 25.9 grams of nitrogen and 74.1 grams of oxygen, convert them to moles, and then come up with the mole ratio, the larger moles divided by the smaller moles. And if it's 1.5 to 1, it would be 3 to 1. So, I'm sorry, 3 to 2, etc. So then you'd find the lowest whole number ratio, and then that would be, then you'd put those numbers in as subscripts relative to each number, whole number. The last one, calculate the molecular formula of a compound whose molar mass is 60 grams per mole. That's the molar mass. And an empirical formula is CH4N. So it would be 60 divided by the empirical formula mass, or the EFM, which would be 12 plus 4 is 16, plus 14, which would be 30. So it would be 2. So it would be C₂H₄N2. That's all I've got. That's the end of your review. But I encourage you to look at all the slides. The better you do this, it's got to become second nature. It's got to become almost boring. But, don't do it until you get it. Do it until you're bored. And then that way you'll always remember it. Okay? Do it till it's second nature, and then teach somebody. Work together on it. Find somebody. If you do it in class or after school or at lunch or at home, at homeroom or before school, I'll give you extra credit. Okay? Talk to you later. Have a good day, and goodbye.